guys, welcome to another episode of MrLopezClasses.com. In this episode we are going to continue in our book of corrosion, marine corrosion. And yes, this is the chapter 6. And in this episode we are going to start to analyze how the bad wiring in my boat, AC and DC, increment the possibility or accelerate the phenomenon of corrosion. Yes, today we are going to analyze in details how the phenomenon of reverse polarity increase the corrosion. The most important part, in my opinion, when you analyze the corrosion is identify if you have leaks of current. And in the next episode we are going to check the procedure, physical procedures to test if you have leaks. But we are going to start in this episode analyzing where are the leaks, where is the possibility, and why in that area, in that wrong connection, I can accelerate the corrosion. This is practically our last course. We have another course of composite material, but this is the last course of this wonderful program. And I normally in my curriculum I put this class, the course of corrosion, just at the end, because I think that you need know everything: electrical connections, electronic connections, the installation of auxiliary equipment like boat thruster, steam thruster, freshwater systems, sanitation systems. And now is the moment that if you understand the boat, if you understand the wiring, if you understand the location of the elements, it's easy for you identify where is the problem of corrosion in my boat. Now we have clear what type of metals are good, what type of alloys are recommended for marine environment, and what type of metals and alloys are not good for marine situations, and we are going to avoid use those alloys, use those metals. And we are going to in this moment we are clear about the environment, how the environment affect my boat, how the environment is important, and why the sacrificial anodes are critical. In other coming episodes we are going to analyze what type of anode is better depending on the type of water. But right now we have clear the concept about the function of the sacrificial anode. What happened in that cathodic reaction with the anodes? What happened with those sacrificial metals? What happened with those special alloys? For what reason those metals are eroded and protect the rest? This is clear. Okay. And now we are going to check, to start to study where are the leaks and how can I avoid leaks of current, both of them, AC and DC, because at the end of the day both of them accelerate the phenomenon of corrosion. Okay, it's clear that the ground in the marina, the ground in the building affect my boat if my boat is not properly protected. Yes, you remember what is the element that we are going to use to protect our boat? Yes, the galvanic isolator. The galvanic isolator is a vital component in the installation of our boat. Alright? And yes, where is located the galvanic isolator? The galvanic isolator will be located in series in the ground line. In series here in the ground line. You cut it, the ground line, and you insert the galvanic isolator over there. Important situation. What is the capacity of my galvanic isolator in order to protect my boat properly? The capacity of the galvanic isolator is in amps. In amps. And the capacity should be minimum equal to the capacity in amps of the main breaker in my panel, in my AC panel. I check my AC panel, I go to the AC panel, and I check what is the capacity of that breaker. It's 60 amps. All right, my galvanic isolator should be minimum 60 amps. This is the criteria. It's according with the capacity of the main breaker in the panel. I select the appropriate galvanic isolator. I have a dual short power connection. It's good idea install double galvanic isolator. In my opinion, yes. Yes, one per each outlet. Normally, where is located the galvanic isolator? If you enter in the engine room and you try to locate inside of the boat where is located the outlets, yeah, for the short power, is pretty close to those outlets the location of the galvanic isolator. Okay, my friends, I recommend each 2 months, 3 months, touch with your hands the galvanic isolator. Normally the galvanic isolator is a little warm because it is absorbing. Remember that the galvanic isolator inside the construction is diodes and capacitors. Remember that if you have diodes to block, that current that you block, you remember in electronics, should be stored in a capacitor. And the capacitor drain through the bonding. For that reason, the case of the galvanic isolator should be connected to the bonding. Normally, the bigger galvanic isolators, the case is metallic, and that case should be connected to the bonding also. All right, my friends, important. The galvanic isolator is the first element to protect my boat from the neighbor boats. Because if the neighbor boats have leaks of current, when those leaks of current try to enter, my galvanic isolator protect. And also, if the ground of the marina, the ground of the building is not good, that excessive current flowing through the ground not enter in my boat. Remember, through the ground, normally the current should be zero. A little. If you have leaks in your home, in your building, it's because some equipment is working bad, or the winding of that equipment is not good. We are going to analyze later that one. And for that reason, you have small currents flowing constantly through the ground. This is the topic of this episode, and the next coming episode. Analyze where are the leaks. Where is coming that small current that is constant? Through the ground, to the grounding system, normally you have 0 or 0.0 something. But if you have 3 amps, 2 amps constantly, you have a leak. You have a leak, and you need to identify where is that leak. Because that leak, at the end of the day, is the leak of current that affect all the elements connected to the bonding. Can you imagine all the fittings, all the through holes connected to the bonding, with the 3 amps constantly flowing through those through holes for 1 hour, 2 hours, 1 day, 2 days, 1 week? Those through holes, at the end of the day, in contact with salt water, produce pitting corrosion, and the pitting corrosion perforate and create a hole, and your boat is sink. That's the problem. Now we are going to start with that analysis. Okay, the first element is install a good galvanic isolator in my boat. If your boat is only a DC boat, is a boat with only DC current, probably, no, you don't need galvanic isolator. Alright? But if you have AC current, if you have AC panel, yes, it's mandatory install a galvanic isolator. But it's a small boat, but you have AC panel? You have short power connection? Yes, I have. Okay, you need a galvanic isolator. You need to protect your boat, and the only way is with a good galvanic isolator. Right, that's the first element. How can I know if the ground in the marina is bad? How can I know if the ground in the marina is affected? There are different ways, but normally with your multimeter in the pedestal, you can check if the ground is not good. It's simple. You remember that picture? That picture in our book of electricity. This is the video related with the wiring, how to wiring a pedestal. You remember that video? Exactly. In that video, I explained in details how is the procedure to wiring the pedestal, and where are coming those big wires, and how those big wires enter the power in my boat. And this is an example of a pedestal with 2 outlets and 2 breakers. Okay, and you have 3 bus bars. In this particular case, it's a pedestal, double phase, and we have three bus bars. One bus bar for hotline number 1, the other one, the red one, for the other hotline, the middle one, the blue one for neutral, and that one on the side, green, for the ground. If you have your multimeter, that multimeter, and you select the multimeter in a volts AC, and now you check the voltage in between, you check the voltage in between hot and neutral, and after that in between hot and ground, and you copy the values. For example, I check with my multimeter between hot and neutral, 121 volts AC. Between hot and ground, 117. Normally, between hot and ground, you have a little less, but it's practically nothing. So millivolts less. If the difference between the reading in between hot and neutral and the reading in between hot and ground is more than 2 volts, you have a problem in the ground. It's simple. You take the reading in between hot and neutral. Okay, 120. In between hot and ground, 119.7. That difference is 0.03. That's normal. If that difference in between both readings, hot and neutral, and hot and ground, is more than 2 volts, more than 2 volts, the ground in that building, in that marina, is no good. And you need to call the manager of the marina and explain to him what is the situation. Explain to him that your boat, when your boat is normally docked in your home, you don't have problems of corrosion. Your boat is clean inside. All the blocks, the motor, generators, the air conditioning equipment, everything is clean. But you move your boat to the marina 2 weeks ago, and right now everything is corroded. And you check the ground in the pedestal, and you found that difference, more than 2 volts. That's the reason. Alright? Okay, I hope you be clear with that concept. Okay, one important thing is install the galvanic isolator. Or other important thing is verify that the ground in the neighbor, in the marina, is in good conditions. And other one is verify if you have wrong connections inside of the boat. Verify if you have reverse polarity inside of the boat. Because if you have reverse polarity, you have flow of currents through the ground and the bonding, and you affect your boat, you destroy your boat. The people cannot imagine how aggressive is a reverse polarity connection in your boat. You can sink your boat. You can destroy the hardware in permanent contact with water if you have reverse polarity. And I am going to explain slow in this episode that situation, the situation of a reverse polarity, and how can I identify if I have reverse polarity. You remember the phenomenon of a reverse polarity, and it's basically when you have a switch, the neutral and the hotline. The hotline enter into the neutral bus bar, and the neutral enter into the group of breakers. That situation. That situation. Yeah, you remember that situation? You have a switch, the hot and the neutral. And now the neutral bus bar is hot. The neutral bus bar is hot, and the breakers interrupt right now the neutral, not the hot, because you switch those wires. The majority of the people respond, Mr. Lopez, but everything is working. The fans, the lights, refrigerator, everything is working. Yes, I have that light on, reverse polarity, in the panel. You remember in the panel what happened? You have one indicator here, red color, to indicate that you have reverse polarity, and you have other indicator green indicating that the power is entering. The red one is solid, is on. This is an indication that you have reverse polarity. This is an indication that your neutral bus bar in this moment is hot. My neutral bus bar is hot. Once again, but everything is working. Yes, everything is working, but it's not good. I am going to explain right now why it's not good. You can identify if you have that wrong connection, checking the panel with the multimeter, and you check the voltage in between ground and neutral, and right now you have 120. Yes, because now the neutral is hot. Remember, when you have a reverse polarity, this is the picture, you connect the indicator. The indicator is an LED, it's a diode. You remember? With two legs. The longer leg have a resistor. That resistor should be connected to the ground bus bar, and the other one should be connected to the neutral. Okay. If you have power in the neutral, immediately the light is on. If you have power in the neutral. Yeah, simple. If not, if the connections are normal, that LED should be off, because you don't have power on the neutral. Simple. Okay, let me explain something what happened. This is the situation. Normally in the wiring in your boat, you have a ground bus bar, the green bus bars, and neutral bus bar, the bottom ones, white color. Those bus bars are independent. Those bus bars should be completely separated, individual, independent. Why? Because if you have one of those, the neutral, with power, and suddenly some electrician, no marine electrician, put together the neutral and the ground bus bar, kaboom. This is catastrophic for your boat. Why? It's simple. Suppose that you have reverse polarity. In this moment, you have power in this bus bar. You have power in the neutral. And a residential electrician did an installation a couple of weeks ago in my boat. And he connected the neutral and the ground, because in the buildings, it's not common, but it's frequent, found that connection, neutral with ground, Mickey Mouse technicians. Now the ground is connected with the neutral in your boat, and your neutral is hot. Then your ground is hot, and your ground is connected with the bonding. Remember, the ground bus bar, this bus bar, is connected with the bonding, and the bonding with the sink. Okay, right now in the bonding you have 120 volts constantly. What elements are connected to the bonding? Through holes, the block of the motors, cabinets, fuel tanks, everything is connected to the bonding. And now the bonding is hot. The through holes in permanent contact with salt water with a high current flowing through the through holes, pitting corrosion is accelerated and perforate those through holes easily. I remember that situation in a boat some years ago in Fort Lauderdale. I am not sure about, I think that the name of that boat was Taka Taka. That boat was docked in the marina in Roscioli. And in that boat, reverse polarity wrong connection produced that situation, and the boat sank. The water penetrated. I remember that boat. It's common. It's very common. It's usual. For that reason, you need to be careful with the reverse polarity. One possibility is because the people connect the neutral bus bar with the ground bus bar. Other possibility is because the owner, the captain, connect outlets and connect the outlet improperly. Remember, my friends, that the connection of the outlets looks simple, but it's not simple. Let me refresh that. The black is the hot. Normally, the neutral is white color. It's that one. I'm going to put blue. And this is the neutral terminal, and this is the neutral terminal. It's white color normally. In European boat is blue. Okay, that's the neutral. And the hot is the black one, the small terminal in the receptacle. What happens if I have in an outlet, I have switched the neutral and the ground. In other words, the outlet is improperly connected, is improperly wired. The neutral and the hot is switched. And I have a couple of fans connected in that outlet 24 hours, constantly. And those fans, the electric motors, are all electric motors. They have to most return to the neutral. Let me refresh a concept that I explained in the class of electricity. The neutral is the return. Remember, in the outlet, you have 120, and suppose that this outlet is for 20 amps. Okay, you have 20 amps in this outlet. And this motor is for 15 amps, the motor that I have connected to the outlet. Okay, in the moment that I start the motor, the motor draw the majority of the current, and after that, when the motor is running, the consumption in amps is a little less. The rest of the current return through the neutral into the ground, because the ground and the neutral should be connected only at the source of the power. The source of the power, you have three different sources of power in your boat. One source of power is the pedestal, the transformer on the marina. At the source of the power on the transformer, neutral and ground are together. The same like in the generator. In the back end, use where the electricity is produced on the stator or rotor, depending on the type of generators. In that board, neutral and ground are connected together. After that, they go separated. And never try to put together inside of the boat, both of them. Yeah? Okay. Right now, the outlet is run. The neutral and the hot is switched. And the blower is, I have two blowers running 24 hours. But those blowers, the return, remember, is always through the neutral. And right now, the neutral is hot and the hot is neutral. Right now, I have a return of 3 amps, 5 amps in the neutral bus bar. I have a current in the neutral bus bar because those outlets are switched. Yeah? And what happens if that neutral bus bar is connected with the ground bus bar? You have that constant amount of current, 2 amps, 3 amps, 5 amps, moving through the bonding system constantly, 24 hours. This is catastrophic. Once again, you have two chances. A wrong connection on the panel, the hot enter into the neutral and the neutral into the hot. This is one possibility. Other possibility is outlets improperly wired. If you have outlets improperly wired, you have returns improperly connected, and you have at the end of the day the bonding. You have at the end of the day the bonding with current. Remember this picture. The neutral is used to return the excess of current not used in the circuit when the motor or the load is running. The excess return to the neutral. Okay, the ground connected from the case of the equipment into the ground is used to drain the jumped electrons storage on the case of the equipment. The ground is used to drain static electricity. If the ground is broken like this here, that static electricity is stored in the case and eroded and destroyed everything. That static electricity tries to be drained through any part. If nobody touched the case, that static electricity eroded the frame of the equipment. That's simple. For that reason, a good tool in order to keep the boat clean, a simple tool commonly recommended for me is this receptacle, the tester. In order to verify with this one, you can verify in the first if the ground is open, or if the neutral is open, or if the hot is open, or if you have reverse in between hot and ground, or if you have reverse in between hot and neutral, or if you have reverse, or if the connection is correct, is appropriate. This is $3, $5 the price of that tester. This is important. Periodically check all the outlets in your boat, and verify if you have an outlet with switch connection and fix it immediately. Yeah, the bonding is designed to drain current in some situations, but it's supposed that normally through the bonding system you have 0 amps. If you have 5 amps constantly through the bonding, that excessive amount of current constant accelerate the corrosion in between dissimilar metals together in contact with salt water. Simple. We need eliminate those sources of leaks in my boat, and this is in the next episode. I am going to analyze how to identify where is the leak. Okay, but right now it's clear that I need to protect my boat with the galvanic isolator properly installed in the ground line. I cut the ground and I insert the galvanic isolator. The other one is keep my boat clean, dry, no water, no humidity. The other one is verify that I don't have reverse polarity. I check with the indicator on the panel, and also with the tester I check in the outlet that I don't have reverse polarity in any outlet. And also I check the panel and I verify that the neutral bus bar and ground bus bar are separated. They are not close, not connected. They are properly isolated one from the other one. And I check in between both of them, in between neutral and ground, with the voltmeter in volts AC, I check that I have zero. This is other way to identify that. And this is simple. Okay, I have a good video clip that we are going to check right now that I explained in our class of electricity, the procedure to verify if I have reverse polarity and how to avoid that. How is in the panel, in the wiring, where the people make those mistakes. This is important right now. We are going to check that. And And yes, this is the procedure to identify that I don't have a wrong connection. And in the next episode, we are going to analyze where is the leak and how can we check the leak. There are three methods, with volts, with amps, and after that it's your decision. Now in the future I am going to use the method with amps. For me it's better, or no, with amps. I prefer amps. It's better. Yes, it's simple, and this is the only way to identify if you have leaks. Because remember, you can stop the corrosion, eliminating chlorine, salt, salt water accumulated in some areas, and also eliminating leaks of current. Both of them. The leaks of current accelerate dramatically the phenomenon of corrosion. Okay, this is the situation. This is the board of AC panel. This is the connection of the board, the wiring of the panel, AC panel, and this is the procedure to identify if I have a leak in that panel.
Okay, guys, this is a board, AC board, that I prepared for use. In this particular example, the board is single phase, but it's exactly the same for two phase or three phase. Alright, this is the typical AC panel in a boat. I have the main AC panel, the main breaker, the single breakers, and the main breaker is receiving the power from the transformer. The transformer is in the back, and the transformer receives the power from the switch selector. This is the AC switch selector. Generator position, inverter position, or short power position. Short power, inverter, generator, and this is the output. This is the switch selector for one position, two positions, three positions, and off. Right? This is the switch selector, AC switch selector. Some people, some technicians, some captains, they prefer, instead of a switch selector with three positions, they prefer three individual breakers with a slide bar. They say, oh, I am going to use right now my boat in short power. I turn on this one on and the other ones off and off, inverter and generator. No, I want to work right now with the inverter. Okay, inverter on, off and off. No, I want to select right now generator. Okay, generator on, off and off. Yeah. Some people prefer the breakers independent, or the switch selector. This is too expensive in comparison with this. Okay, let me explain how is the wiring in the back of those three breakers when you use three breakers individuals instead of the switch selector. The procedure is this. This is the procedure. This is the short power. This is the pedestal, and the pedestal produce, in this particular example, double phase and neutral. Phase 1, phase 2, and neutral. And I have three breakers. One breaker for short power, other breaker for inverter, and other breaker for generator. This is the inverter, this is the generator, and this is the short power. Okay, this is the input from the short power, hot, and neutral in the middle. This is the input from the inverter, hot, and neutral. And this is the input from the generator, hot, and neutral. Okay, let me check. The output is exactly the same, hot, and neutral, hot, and neutral. But I am going to connect together the hot of the first one with the hot of the second one with the hot of the third one. And from this connection, the black one, this is the output hotline to the AC panel. I am going to do the same with the neutral. This connected with this and connected with this, and from this is the neutral going into the AC panel. And with the phase number 2, it's exactly the same. This one connected with this one, connected with this one, and this is the output for the AC panel. In that way, if I turn on this breaker and this off and off, I am going to use only the short power, the power from the pedestal, and no power from the inverter and no power from the generator. Oh, I don't want, right now I want to use the inverter, off, and this one on. Or I want to use the generator, off, and this one on. This is the procedure to use three individual breakers instead of the switch selector. Some captains prefer the breakers separated. It's less expensive. is easy to do the troubleshoot in comparison with the wiring on the switch selector. Right now, I am going to explain to you the procedure to do the wiring on the AC panel. Once again, we have the main AC panel, main breaker, individual breakers. We have the inverter. The input of the inverter is DC power, and this is the output of the inverter, AC power. And we have the short power. The short power connection. This is the outlet. This is the short power card. This is the power coming in, and this is the power coming from the generator. The generator is not connected in this moment. We have a generator, we have inverter, we have short power or short power inverter generator, depending if you use switch selector or if you use individual breakers. And additionally, we are going to connect the ammeter, the voltmeter, and the frequency hertz. Frequency, voltmeter, and ammeter. And in the breakers, in the individual breakers, we have one breaker for lights, other breaker for the battery charger, and we have another breaker for outlets. Those outlets, this is basically an example of the real situation. Okay, let me check. I show to yours in the back what happened. This is the situation in the back. This is the situation in the back. And now we are going to check the panel step by step. All right. This is the short power. The short power, hot, neutral, and ground. The ground goes directly to the ground bus bar, and the ground goes directly. This is the isolator transformer. Pass through the isolator transformer. Continue is interrupted, and you install the galvanic isolator. The ground continue into the bonding system, and from the bonding system finish into the sink. Let me repeat the path of the ground. The ground in this particular case is here. That's the ground bus bar. The ground bus bar goes directly pass through the transformer and is interrupted in order to insert the galvanic isolator and continue over there. When you insert the galvanic isolator, remember that episode, the episode related with the galvanic isolator, the capacity of the galvanic isolator in amps should be exactly the same capacity of the main breaker on the AC panel. This is the main breaker, excuse me, this is the AC panel, this is the main breaker, and those are the individual breakers. Okay, the main breaker, the capacity of this breaker, in this particular case, is 30 amps, and the capacity of the galvanic isolator is 30 amps. This one should be equal to this, and also the capacity of this and this should be equal to the capacity of the output breaker of the generator. 30 amps, 30 amps, 30 amps. It's exactly the same for all of them. Okay, this is the ground. Now, hot and neutral enter in the breaker for short power. Hot and neutral, this is the input. And this is the output from the inverter. Hot and neutral, and this is the breaker for inverter. And this is the power coming from the generator, hot and neutral, and this is the output, hot and neutral. And right now, I am going to connect the neutral of this connected with this, and the neutral of this connected with this. All of the neutrals are connected together, and from one of those connections, this is the neutral going, passing to the isolator transformer, continuing, and entering into the panel. The neutral bus bar and main breaker. After the main breaker, the hot line enter in the hot bus bar, and this is the output of the breaker. This is the output for lights, this is the output for outlet, and this is the output for battery charger. Once again, I am going to repeat. For example, in this moment, I am going to wire the power coming from the short power. Hot and neutral enter in the breaker for short power, and this is the output, hot and neutral. Okay, the power coming from the inverter, hot and neutral enter in the breaker for inverter, and this is the output. And the power coming from the generator, hot and neutral enter in the breaker designated for the generator, and this is the output. Okay, the outputs should be connected together. Neutral of the generator connected with the neutral of the inverter and connected with the neutral of the short power. And from that connection is the neutral of the output. Okay, the hotline of the generator is connected with the hotline of the inverter and the hotline of the shore power, and from that common point, this is the output power passing through the isolator transformer, and this is the output of the isolator transformer, hot, entering in the main breaker. This is the output of the main breaker entering into the hot bus bar, and those are the outputs of each individual breakers. That's clear? Alright. In each breaker, you have in front of the breaker, if you check in the other side of the panel, let me show to yours like this. In front of each breaker, you have one LED. When you activate the breaker, the LED should be on. The LED, for this particular case, for this particular example, is similar to this one. It's an LED, one leg for neutral and the other leg for hot. Okay. All the LEDs, they have the neutrals, the yellow ones, connected to the neutral bus bar. And the hot is connected in the output of the breaker. When the breaker is activated, immediately the LED is on. Because the light, one leg is on the neutral bus bar and the other leg is connected here in the output of the breaker. This is the breaker for the light. Now we are going to turn it, the board, and we are going to check the connection. The LEDs should be connected in the output of the breakers, not in the hotline at the input. Because if you connect here, the LEDs are on all the time. That's not good. Okay, this is the procedure to connect the procedure to do the wiring on the breakers. Okay, now we are going to connect the voltmeter and the ammeter. Alright, this is the ammeter, this is the voltmeter, and this is the frequency. Okay, the ammeter, this is the donut, this is the hotline. You remember the hotline coming from the output of the transformer, enter here, pass and enter in the main breaker. And the donut is here. The cables in the output of the donut enter in each terminal of the ammeter. Simple. The voltmeter, one hotline is connected here with the hotline bus bar. And the neutral is connected to the neutral bus bar. And the frequency is connected neutral with neutral and hot with hot. That's too simple. Connect voltmeter, frequency, and ammeter. The ammeter should be with donut, and the donut should be connected through the hot line cable. How can I verify if the ammeter is working properly? I can verify that one with my clamp. With the clamp. The clamp is used to read amps in AC power. I recommend the clamps for AC. Okay, where you connect the donut? Okay, I want to know the consumption of all the system. Okay, I am going to read on the hotline at the input of the panel. And now I read how many amps are in the consumption. No, I want to check the consumption only of the battery charger. When the battery charger is, I turn on the breaker of the battery charger and I check here on the hotline of the battery charger. It's only on the hotline to read amps in AC power. With the voltmeter, I can check the voltage. I can check the voltage in any part of the system. I only select voltage and I check the voltage in between the neutral. I put one terminal in the neutral bus bar and I check in the output of each breaker or in the hotline or at the input. That's the procedure to use the voltmeter. Voltmeter and the clamp. Once again, the connection of the isolator transformer. The isolator transformer is connected in series with the main power coming out from the breakers or the switch selector. This is the switch selector and those are the individual breakers. The power enter in the isolator transformer, the power continue into the main breaker. The ground goes directly separated, pass through the case of the transformer, continue, is interrupted to introduce the galvanic isolator, and the ground continue, enter into the bonding system. This is the bonding system, and from the bonding system you have the sink, and the sink connected with the water. This is the typical wiring of the AC panel, and this is the procedure to do a troubleshoot to verify if one breaker is working or not. You use the voltmeter. To verify the consumption in amps, you use the clamp. Let me show to yours right now. Alright, this is in this moment is connected to short power. I am going to select short power, inverter off, generator off. I have short power. I have power on the short power light. The LED is on, and right now I am going to connect the lights. Okay, the lights are on, or the battery charger. The battery charger start. The lights start, and the outlets. Those are the outlets. This is my boat. The light is on because it's receiving power. What is the meaning of that? The green light is on is because my polarity is properly. My polarity is properly. What happens if the reverse polarity will be on? If the red light for reverse polarity is solid, is on, it's because I switch the hot and the neutral on the panel. I connect on the neutral bus bar the hot, and the neutral is on the breakers. What happens in that case? If I have reverse polarity here, probably the light is on. This equipment is working, the outlets are working, but the neutral, let me explain that one. This is a critical situation. I'm going to turn off everything. Let me explain what happens if I have reverse polarity. If you have reverse polarity, it's because you connect this one, the neutral, on the hot bus bar, and you connect the hot on the neutral bus bar. You make a mistake and you connect the neutral on the hot and the hot on the neutral. Okay, what happens if you have reverse polarity? If you have reverse polarity, the neutral bus bar right now is hot, and the hot bus bar right now is neutral. Mr. Lopez, but I think that everything is okay because the light is on, the computer is on, everything is on. Yes, my friend, everything is on, but right now the neutral bus bar is hot. What happens if for some reasons, look at this. This is the neutral bus bar, and the other one is the ground bus bar. What happens if for some reasons you put one equipment, you connect the neutral with the ground, or the ground with the neutral? Because there are technicians, there are electricians dedicated to work in residential electricity or industrial electricity, and they say that the neutral and ground can be connected together. This is not possible in marine applications. Remember, in marine applications, only at the source of the power, neutral should be connected with ground. After that, should be separated. Separated bus bar for neutral and separated bus bars for hot. Never put together. If somebody enter in the boat and work installing other equipment and connect together this with this, and this one right now is hot, is catastrophic. If this one right now is hot, and you connect suddenly the neutral with the ground right now, the bonding is hot, 120. Remember, what equipments are connected to the bonding system, to the bonding bus bar? You remember? The through holes, the metallic fuel tanks, all the metals inside of the boat shall be connected to the bonding metal. If the bonding metal right now is hot, the corrosion in the fittings, the corrosion on the through holes, the corrosion on the transducer is accelerated, and the boat suddenly is sink because those elements are perforated because the corrosion is accelerated. This is critical. If you have reverse polarity in a boat, immediately the bonding have power. The bonding have AC power. What is the enemy of the bonding system? Okay, the enemy of the bonding system is the current, the extra current. If the extra current is AC, is more catastrophic because accelerate the corrosion in between two dissimilar metals together faster. What happens when you have two dissimilar metals together in a marine environment? You have galvanic corrosion. What happens if additionally when you have two different metals together, you have extra current passing through the metals? The corrosion is accelerated, especially if in between both of them you have humidity. The corrosion is accelerated, and the more noble metal attack the less noble metal and destroy the less noble metal. This is catastrophic. For that reason, if you have the light of reverse polarity of the reverse polarity indicator on, you need to solve the problem immediately. If not, probably your bonding bus bar right now is powered with AC power with 120 or 240. Be careful with that. This is the procedure to do the wiring in AC power. I think that is simple. You need to be careful, use the appropriate tools, and use goggles. Be careful with the AC current. The AC current is critical. It's easy work with DC current. When you work with AC current, you need to be careful. Be careful with the reverse polarity, because normally on the neutral and on the ground bus bar you don't have current, but if you have reverse polarity, it's possible. You have reverse polarity because somebody switched the hot and the neutral, or because the short power line, the hot and the neutral is switched. This is other possibility. Now, okay, I hope you enjoyed this video the same that I enjoy preparing the class for yours. Don't forget the procedure to use the clamp always on the hotline, and the procedure to use the voltmeter in between hot and neutral, or in between hot and hot when you are reading the voltage in between two phases.